Hello everyone, welcome back to another C# video. So from this video onward, we are going to create a repository for our video tutorials, and I'm going to upload the codes we are talking about during this course to the GitHub. If you guys want to download and copy the code, you guys can go to the GitHub repository and download the codes. So I have created a GitHub account. If you guys don't know how to create and set up your GitHub, I have a playlist about Git. I'm going to provide the link down below, and also you can click on this I button here at the top right corner. So this is my GitHub account. If you click here, go to profile. So this is our profile. I'm going to create a new repository for our C# tutorials. I click on that, click on your repositories. So I click on new. So I'm going to give our repository a name. I'm going to give it C#. Tutorials. So I'm going to leave it as public, then create my repository. So this is the repository created. As you guys can see, this is the link or URL to my repository. This is my Code with Cougar is my account name, and /C# tutorials is my repository name. So this repository is on the cloud in the GitHub. I have to download or link this repository to my local machine. So select a folder in your computer and copy this link or this URL. If you click here, or you can right click and copy this URL, go to your local machine and open the folder you want to clone or download this repository from GitHub or from cloud. So right click and open your git bash or any command line you're using. So here write git clone and paste the URL we just copied. Right click and paste. If I enter here, it's going to clone the C# tutorial repository from cloud to my local machine. So I have a copy of this cloud repository in my local machine. Right now, if I refresh, nothing is in this cloud repository. So I'm going to open my Visual Studio and create a new project. I'm going to select console application. Type conversion is going to be our project name. Then I'm going to select the location we just downloaded from our GitHub repo. C# projects. This was our GitHub. As you guys can see, if we open this folder, we see a hidden file .git, which shows that this folder is a GitHub or a Git folder or a Git repository. Select this folder and let's create our project inside that folder. So our project is created. I have written some note here. I just copied and pasted my note. So we're going to talk about type conversion. What basically type conversion is, it refers to the process of converting one data type to another data type. In C# we learned about different data types. For example, we had byte type be equal to, for example, say 1. So we learned that byte is going to take 1 byte of memory location. We also know 1 byte is equal to 8 bits. So a byte data type is going to take 8 bits of memory location. Then we had a short is equal to, say, 1. We know that short is going to take 2 bytes of memory. That is going to be 16 bits. We also had int I equal to 1. We know that an integer in C# is going to take 4 bytes of memory, and that's going to be 32 bits. Then we had long. For example, L equal to a long number. Long is going to take 8 bytes of memory and 8 bytes of location in our memory. That's going to be 64 bits. So whenever we want to convert or change one type to another type, That's called type conversion. Basically, we have three type of type conversions. We have implicit type conversion, which is done automatically. It happens when we want to convert a smaller type to a bigger type. So basically, a byte type can fit in a short type, in a long type, and also in an integer. Because byte takes only one byte can easily fit into 2 bytes or 4 bytes or 8 bytes. If it is the case that we are going to convert a smaller type to a bigger type, so that is automatically done, and it's called implicit type conversion. It's done by compiler. So the target type can accommodate all the values of the source type. So there is no chance of data loss. When the compiler is 100% sure that there is no chance of data loss, then the compiler implicitly convert one type to another type. For example, I have if I want to convert this byte b into integer, int my int equal to b. So if I print my int, so it should not complain. The compiler doesn't give an error, and it's okay because byte can easily fit into integer. So a 1 byte data can easily fit into a 4 byte data. But vice versa, if we want to convert an integer to a byte or to a short, a 4 byte cannot fit into a 2 byte or 1 byte. So there is a chance of data loss. In that case, we have to explicitly convert one type to another type. So in explicit conversion, we require a cast operator to cast or change one type to another type, and also it can result to a loss of data since we are trying to fit a bigger data into a smaller data. Our bigger data may exceed the limit of the smaller data, and there might be a chance of data loss. So basically, the target data type cannot accommodate all the values in the source data type. For example, if I want to byte my byte equal to if I wanted to equal it to I or integer, so the compiler gives an error and it doesn't compile. It says cannot implicitly convert int into byte. An explicit conversion is required. Okay, so we gotta use a casting operator to explicitly telling the compiler that we want to convert this integer type to a byte type. So we inside the parenthesis we write byte. So right now the compiler doesn't give an error. Our integer is converted to the byte type, and the error is gone. If we want to print my byte, so we can see that 1 is printed. Suppose integer, we want to store the maximum value of integer or a large number that cannot fit inside a byte. So there might be a chance of data loss, and we may lose our data. If we print right now, we can see that 221 is printed. So where we have here we have a large number and only 221 is stored inside the my byte. We have a lot of data loss here. That's why explicit conversion sometimes is not safe. We gotta be careful. The other conversion is a conversion between incompatible or non-compatible types. For example, if we have a string representation of a number, suppose I have a string snum equal to 123. Okay, so this value is not a number since it is inside double quotes, so we know that it's a string type. And if we want to convert this non-compatible type to an integer, and all these are compatible types since they're all numbers, and this is a string representation of a number, so this is not compatible with these types. So in that case, we have two methods. Either we can use the parse method, or we can use the convert class that has a lot of static methods to convert one type to another type. So let me comment out these lines of codes. Let me define another integer int my int equal to we can use the parse method int parse, and we pass our string. So this is going to parse this string representation of a number and return an integer, and that integer will be stored in my int. if I print my int, so 1 2 3 should be printed. So this 1 2 3 is integer, not a string anymore. The second method is we can use the convert class, my int 2 equal to convert. This convert class has a lot of static methods. If I press dot, we can see that 2, all the methods start with 2. We can see to byte, to car, to date time, to double, to n16, which is a short, n32 is which is an integer. If I select n32 and pass my string, which is snum, this is also going to convert this string representation of a number to integer. Let me print my int2. So this was the two method to convert a string into a number, a string representation of a number into integer or double or float. We can, if we want to convert it to float, we can write, instead of int, we can write float dot parse or convert dot to float. Then we pass our string inside that. So convert is a general purpose. It is used widely. It's used more than parse, because if we have a null string, then the parse method will throw an exception. We can see that it says argument null exception, it throws null exception, whereas the convert method can handle the null string and return 0. Let me stop my execution. Let me comment out this lines of code. But in case of convert, we shouldn't have any issue, and it should handle the null exception also. We can see that our program didn't crash, and the convert, the toString method, returned 0. So this was a quick video about type conversion in C#. Please don't forget to subscribe to Code with Cougar, and see you in the next video. Bye bye.